Hi, we are Group 66. So our topic today is database encryption. Firstly, we'll talk about typical crypto systems that could be applied in database encryption. As we know that public key cryptography uses a public-private key pair, this characteristic could be leveraged to encrypt and decrypt the contents of the database as well. The public key could be used to encrypt and write the protected fields, while the private key could be used to read the encrypted fields. One implementation we found in a research paper by Chang and Chen adopts RSA to encrypt the databases. The process follows the standard RSA algorithms, except that each protected field has their own unique public-private key pair. So it allows the database manager to better manage who can read or write a certain field by granting them the public key or private key associated with that field.
Symmetric cryptography uses the same key to both encrypt and decrypt the database, which means anyone who has the key for encryption can use the same key to decrypt any of the data that has been encrypted. For example, Advanced Encryption Standard, or AES, is one of the symmetric encryption algorithms. AES likes to arrange things in a 4x4 grid. The overview of what AES does is shown in this diagram. This is our plain text. And firstly, we're going to take a part of our key and perform an XOR operation, then perform subbytes, shift rows, mix columns. And this is going to be our substitution, and this is going to be our permutation. Finally, at the end of each round, we're going to add a run key, and this is finally considered as one run. The only thing to mention is that the mixed column is in all the rounds except for the last one, because the permutation has no effects on the last one, just permutes the output.
When using asymmetric crypto systems for database encryption, like RSA, they're considered secure as long as integer factorization problem and RSA problem are still considered hard. But as asymmetric crypto systems need to perform exponentiation, while symmetric crypto systems are mainly based on bitwise operation, XOR, like we mentioned before. So asymmetric crypto systems consumes more time and resource, hence will cause a greater reduction on the performance of the DBMS than symmetric crypto systems. For symmetric crypto systems, it is simpler to implement in terms of confidentiality. Symmetric encryption is less secure due to the use of a single key for both encryption and decryption. And the encryption schemes we just talked about can be applied to 3 different levels. Application level encryption schemes are applied within the application. For instance, in a web app adopting this scheme, sensitive data from user inputs will be encrypted by a function provided by the application. And then the ciphertext will be stored in the database instead. However, the indexing feature of the DBMS could be broken as ciphertexts are stored. Database level encryption schemes are handled by the DBMS itself. They require encryption features like from DBMS, which is a limitation compared to the other two. A widely used example is called transparent database encryption, such as MySQL's enterprise encryption. And lastly, file system level encryption schemes are implemented at the OS or physical layer. They directly perform encryption on the file system of the OS and the storage device. So it only has the granularity of disk or storage volume level, which is relatively coarse compared to the other two.
NoSQL databases are available as open source databases to handle many kinds of unstructured data. In this presentation, we only focus on MongoDB and discuss its related security measures. Firstly, we're going to talk about Kerberos authentication protocol. The protocol was named after the character Kerberos or Cerberus from the Greek mythology, the ferocious three-headed guard dog of the Hades. Kerberos is a computer network authentication protocol that works on the basis of tickets to secure the network, which provides authentication service and mutual authentication between user and server. It requires a trusted third party, and it may use cryptography during authentication. Kerberos can work using symmetric or asymmetric cryptography. The main drawback of Kerberos is that in the case of symmetric cryptography adoption, since all authentication are controlled by a centralized key distribution center, compromise of this authentication infrastructure will allow an attacker to impersonate any user. And the other drawback is each network service that requires a different hostname will need its own set of Kerberos keys. This complicates virtual hosting and clusters. Next, we are going to talk about the CryptMDB. The CryptMDB is a practical encrypted MongoDB, which utilizes an additive homomorphic asymmetric crypto system called Paleo crypto system to encrypt users' data and achieve strong privacy protection. A notable feature of the Paleo crypto system is its homomorphic properties along with its non-deterministic encryption. The Paleo algorithms allows Bob to decrypt the message by using a private key without knowing the random number R. Decryption is also quite difficult to compute when Q and P are large positive integers and without knowing a private key. Therefore, it is helpful to prevent eavesdropping.
Key management, we need to generate the keys first. For database encryption, key generation is similar to message encryption. You generate a random number first, then use this number and some algorithms like RAC to encrypt data. Where a true random number is difficult to generate, a component called locksmith is introduced to generate a strong procedural random number. Another method is more complicated. Use some strong algorithms like RAC to generate a master key that ensures high level of security but slower the encryption speed. Then dynamically generate word keys by master key with ideal algorithm. Use this key to encrypt data with short response time. Then different distribution methods will apply. The first distribution method is traditional that uses certificates and communicate with certificate authority. The second method will use the security catalog to ensure the public key belongs to the user we really want to share the data with, and it will not communicate with certificate authority to save time. Database encryption also has some challenges. The first one is it can't resist an internal attack. It has a solution that decrypts in another server where there is no system to perform this function. Performance and encrypting existing databases are two more challenges to make the encryption system work efficiently and better. 5 design considerations are pointed out. First 3 I already introduced above. Last 2 discussed that encrypted database size should not be too large compared to original database, and keep the internal database functionality intact. Thanks for listening.